All right, welcome back, everybody. Today's session, we are still marching right along. We're going to continue on, I believe, with loads and boundary conditions is what we have. I have promised to do today, so I will do that. I will kind of also caveat this loads and boundary conditions with we're going to need to redo loads and boundary conditions in the near future. So this is certainly something that's coming up because, as we're going to see, loads and boundary conditions hasn't fully been, say, switched over to kind of a new workflow. In fact, most of loads and boundary conditions is still going to be done via a panel, which maybe gives you some reassurance that the panels are still there. So if you do ever need to fall back on those, they're still there. But loads and boundary conditions will be getting a facelift and overhaul to be hopefully a little more usable, a little more. We'll see these things called controls, so we'll be able to control them. What happens to the underlying mesh or nodes if we remesh? Do we, remap the load? Is it a total load? Do we copy the magnitude? There's going to be all these kind of more engineering type of options for what we do with loads and boundary conditions. But what I wanted to do for the first part of this series is I wanted to get us through a running model, and a model runs if there's loads and boundary conditions on it. Else, why are we even doing this, right? If we just want to mesh something and never, analyze it, that seems a little silly. So we're going to talk loads and boundary conditions today as a means to an end, right? As just getting us to a running model. Okay. So under the Analyze ribbon is where we will find most of our loads and boundary conditions. When I say most, pretty much all of them. I'm going to caveat this, and again, I was even on the fence of whether I should do loads and boundary conditions, but I'm going to. Okay, so let's just kind of maybe quickly walk through some of these. Some of these I won't talk about. Some of them will have their own little webinars, like pretension. That deserves its own little webinar. Yeah, pretty much that one. Okay, so these are multifunction buttons. Okay, so this one button will contain moments, pressures, and forces. The boundary conditions, I believe, will open up into constraints. There's some inertia relief card in here, as well as MPCs. Maybe for after the session, but curious to know who uses MPCs and RB2s kind of interchangeably. That actually came up the other day, so a little curious about that. Enforced displacement is here. Like I said, a lot of these tools are going to point you back to a panel. Okay, they just haven't been fully migrated yet. We don't have a complete workflow for them that is not dependent on the panel. Okay, so for some of my newer users, this looks pretty foreign. I understand. For some of my, I don't want to say older, for some of my senior users, this is, maybe this brings back some nostalgia, right? So, but all of these are going to really point us back to a panel. As far as creating the loads and boundary conditions go, they all need kind of what we call a support entity. So most loads and boundary conditions eventually get applied to a node, but maybe you interact with them through an element or something. Okay. But let's say I want to put a force on the top left corner of this part. Okay. So I will come and select the force little section of this icon. Zoom into the top left corner. Node. We'll still get a little graphical representation, but some of the nice selection things that you know and love are kind of gone. So we can still drag a box. We should still have the ability to change whether we want a circle or we want the lasso or something like that. But you're going to notice that right-click within the GUI when the panels are open, the tool is a little different. It just responds a little different. So we do still point you back to all the advanced selection is going to be contained under this yellow nodes button. If you wanted nodes by face, by set, by those different types of things. So again, not ideal, but it's what we're dealing with right now. I'll select this node. For applying a load, it needs information like direction and magnitude. So those are going to be some of the info that we need to fill out here. So maybe 100, again, I don't know units, so let's just do 100 bicycles in the X, Y, or Z axis if I happen to have it normal. But I do want to talk about this N1, N2, and 3, this idea of defining a plane on the go, which I think a lot of people would probably like to do. So especially if I want this, to be normal or a certain direction, I can define a couple of nodes on the fly or on another portion of my model that define this. And this is either going to be N1 to N2, so I could just do a simple vector. So N1 to N2, so this is the direction of the vector. I don't need the third node. Okay, I can hit create here, and it will make that load in that N1, N2 direction, just to kind of show. Let me reject that. If I apply the third vector, then this becomes the right-hand rule, right? So whether I want 1, 2, 3, usually if I'm doing the right-hand rule, I'll kind of confine it more to a single element because that'll be a little more planar, right? So N1, N2, and 3. So via the right-hand rule, this should be going, down, to the outside of my skin, right? So maybe like an internal type of force. Someone leaning up against the side of your airplane, taking a nap. Okay, great. Okay, so that's going to be the force. So that's what the N1, N2, and 3 mean. It's obviously not very clear, but these you can be either just N1 and 2 for a vector, N3 to define a vector via right-hand rule. Yep. Okay, so that's how these kind of loads and boundary conditions are going to go. So, boundary conditions are the same way. If I wanted to make a constraint, right, just want to come and clamp a node or a couple of nodes, I can just click kind of willy-nilly, lock the degrees of freedom that I'd like, and hit create. The create operation is quite important here, so you can't just select things. Perfect. So the second part of loads and boundary conditions is how they get organized, is what I would also like to discuss. And the way that these get organized is via load collectors. Okay, so you can think of I have seen aircraft models that have millions, tens of millions of individual loads, but not all of the loads act at the same time on the model, right? There's going to be landing loads, there's all of your flight loads, there's thermal, there's all sorts of different groups of loads that need to be grouped together. And that's what a load collector does, okay? And that's what is probably the easiest way to kind of do some of these things, okay? So in this model that I'm currently showing, I already have some load collectors, but I'm going to just double click on my load collectors to open this load collector browser. So there's already one that's a force and some SPCs, and I can show. So I already have clamped the entire edges of these. I can just right click and show these, right? So show, hide, isolate, if I so choose. But I want to make a new one, right? So this is a new force that I'm making. So there's a force on that side, there's a force on this side. They don't act at the same time, right? So I'd like to go and create a new collector. I'll call this force 2. Okay. And the SPCs are fine. Okay. But there's always this idea of where do my loads go. This one, as you can notice, this force 2 is bold, which means it's my current collector. Okay. So that means anything new that I make, so if I go to make a new force, put it in the middle here. So again, I'll pick my N1, N2, and 3. I'll be a little less specific. Okay. One load was created. It automatically went into the current collector. Okay. Because it's bold, it's a new entity. That's just where it gets organized. Okay. So a very common workflow. I wouldn't say that we're going to make hundreds of thousands of load cases manually. There's a better way to do this, but that's for next week. It's not uncommon to just go ahead and right click, create a new load collector, call this, 5G load land, half fuel, be specific about what you call this. Oops, whatever. Clearly not a good speller. And then this is where I would go ahead and put those loads, right? So maybe we're going to simulate some type of a pressure load. on this face. It's normal, you know, it can have a magnitude. I do usually like to point out that this could be some kind of an equation as well. So especially for things like pressures, and it can just be something simple like I want you to take the nodal position, go 2 times x, right? So x is this way. I'll go ahead and hit create, and we'll see that. Well, I think my x position is quite large. So you see, you know, a preload of 1.17 e to the 5, but then as we go positive in the x, it's 1.18, etc. So these aren't, they look constant, but this is kind of an equation based on where they are relative. Okay, this could be, equations are available in here as well. And people always are confused, like, how do I use the equation? Well, it's pretty basic, to be honest. It's just, take a integer times x, y, z. Those are the kind of things you can put in there. It could be sine of x if you want to be crazy and do some crazy math as well. So, okie dokie. And those all went into my current collector is what I was kind of trying to say. Okay. The last thing you might be saying was, well, Blaze, you made this force over here and you didn't want it with that one. I say, that's absolutely right. The ability to organize forces into particular collectors is kind of the last thing that I'd like to talk about here. Because everything else is just clicking on a button and understanding I want to enforce displacement, or I want a temp, or I want some type of flux, etc., etc. I don't know all the specifics you want to put in your model, but I know that this is a very common use case of you're in the creation mode and you forgot to organize, and you're going to organize later. So kind of the easiest way to organize is just to select your load in the model and right click and organize. Okay. So kind of bring you to an organize option. So that load is already in here and it's saying, well, where do you want the destination to be? And I should be able to pick. I like this option of picking from my list. So I said, well, I really want that load to be in this force 2. And this is going to show you the ID, but if you hover over it, it'll give you the name and those type of things. And I'll go ahead and hit, move. And then I can just kind of visually see that it's now this really ugly brown. Let me pick brown. Such an awful color. Okay. So that's the loads. Some of my more senior users were also kind of used to seeing what was current in the bottom right over here, because this view, if you're in the model browser, gives you no information about what your current collector is. So down at the bottom right, again, this is going to be the very bottom right of my screen, there is an ability to kind of right click to show what your current options are. So you can hide or show these different types of things. But showing your current load collector could be of use here. And you can also swap what is current down here by just clicking on them and then picking a new one. So component, collector, subcase as well, if you have those. Different include files. So I don't think we've talked include files yet, but still a very common way to organize models. Know what current include file you're in, so you know that you're putting the right pieces in the right places on the first try. You can always go and change it, but there's nothing like doing it on the first try to just rub it in everyone else's face that you know what you're doing. Okay. So those are the load collectors. The final step of any type of load process is going to be how they step together, right? And so this is what we'll call a load step. So maybe, like I said, these forces don't act at the same time that this force does. Maybe these pressures act, it's particular, they're just different combinations of all of these, and that's going to be controlled by the load step. So back under analyze, probably the easiest way to do load steps. I don't like this load step manager, but I'll kind of you have the option for this load step manager. Not my favorite. I usually just end up right-clicking and creating a load step. So there is a load step manager here. Again, not my fave, but under the model browser, right-click, create a load step. And then here is where you just fill out the form. Okay, and this is going to be specific to the solver profile that you're in. So Abacus looks a little different than Nastran, looks a little different than OptiStruct. The OptiStruct one does have the ability to kind of parse down your solution type, but in no way are you kind of solution type dependent. So you can just pick linear static. Linear static is going to get rid of all like the NL cards, nonlinear cards, NL param cards. None of that applies to a linear static run. So it just kind of condenses what's shown. And then you come and grab your SPC. Those are going to be your constraints, which loads get applied to your model. And there's all sorts of different load, options in this. We can't cover all of them right now, but I just want to make sure that we do our due diligence to make some stuff. And once we're done selecting this, we can hit close. There's all sorts of options in here as well that can also be selected for load case dependent outputs. I think that's kind of nice. You don't have to do global output requests. If you know for this load case that you're more interested in, you want grid point forces for free body diagrams later, you can just do that per sub case. And the final thing that I want to talk about, this is like the Lord of the Rings, that movie that just never ended. Some of you are going to notice that there is a new thing called a load step input. You might be looking for your IGRL card, something for do a modal analysis, something that is kind of solver specific as far as the solution setup goes. So a lot of these were in a load collector. We have now moved them to a load step input. So I will make one of these to kind of show you what this is. So the load step input is going to be our modal cards, right? So where you type in your either a range of frequencies that you'd like swept over or in number of modes, which is normally what I do, the first 10 modes per se. Okay. And then this is your IGRL card. So if you are looking for your IGRL card in a load collector, it's not there anymore. Sorry. Okay. Load collectors don't contain that. And load collectors are going to contain less and less solver specific information. So, all right. Well, that kind of is a bummer of a way to end today's webinar, but that's where we're at in our lives. So if you do have any questions, feel free to reach out to Altair support. I'm more than happy to help. I'm going to go ahead and sign off for today, and we will talk next week.